Keep it moving, please.
Order in. 1 chicken blue bag, 1 stir-fry pilaf. Order in.
The breaking of a glass can be a shattering experience. It can disrupt a smoothly running operation and expose workers and diners to unexpected danger. Which is why at Libbey Glass, we put so much emphasis on making glassware that meets the needs of the food service industry in terms of both safety and durability. We have managed to enhance the durability of the glass we make considerably. And for the next several minutes, we'll talk a little bit about how that's done. We'll also let you know about the various forces that cause glass to break and how the people who handle the glass can counter those forces and enhance the life of the glassware just by following a few easy-to-remember guidelines. The materials with which glass is made are pretty much the same the world over. Glass is composed mostly of sand, soda ash, and limestone. These raw materials are melted in furnaces at temperatures of 2,800 degrees Fahrenheit. After the glass is melted, it's fed into glass-forming machines and then cooled slowly. As it emerges from the cooling process, the glass is referred to as annealed glass. While annealed glass is already very strong, able to withstand a force of up to 75,000 pounds per square inch, it is, however, prone to surface damage. Jostling and banging glass causes microscopic flaws to form in the glass surface. Simply dropping silverware into the bottom of a glass can cause this kind of damage. What happens when flaws build up on the surface of a glass mug or tumbler? The flaws serve as stress points, which multiply the force of loads applied to the glass. They are, in effect, tiny gathering points for stress. At Libbey Glass, we've been designing and fabricating glassware for 180 years. In that time, we've thoroughly studied and charted the stresses which glass undergoes in everyday use. And we've developed a variety of ways to counteract those stresses. Let's take a look at exactly what the forces are any piece of glass has to withstand in the modern food service operation. Generally, glass strength is measured in two areas: mechanical strength and thermal shock resistance. Mechanical strength describes the ability of the glass to withstand impacts, including the kinds of abrasions and scratches we were discussing. Also, when glasses are stacked, not too gently at times, when they're jostled against one another, when they tip over, and when they are dragged or scuffed across a hard countertop or sink, their surfaces are damaged. This chart shows how as surface flaws increase, glass strength is reduced. As you can see, the weakening effect is dramatic. Thermal shock resistance is the extent to which glass can undergo extreme swings in temperature without breaking. Glass is a very poor conductor of heat. In fact, one end of a glass rod can actually be heated to the melting point, while the other end is still cool enough to hold. This simply means that it takes glass a long time to heat up or cool down. So when a glass is heated or cooled quickly, immense stresses build up on the surfaces of the glass that are responding to the newly introduced temperature. In fact, for every degree Fahrenheit that the surface of the glass is different from the interior, the thermal stress on the surface is approximately 25 pounds per square inch. Thus, with a fast 10-degree change, the stress on the surface is 250 pounds per square inch. You begin to see why the surface flaws we discussed can take such a devastating toll on glass. The design of a piece of glass can also help determine its durability. Take a look at this design. A flared glass produced in Europe. Because of its design, the primary point of contact is at precisely the weakest point of the glass, the rim. Now look at how a seemingly minor design change can make a big difference in durability. By bringing the rim in just a few hundredths of an inch, we were able to move the point of contact away from the rim, enabling the glass to distribute the force. The results are dramatic. The wall thickness of a glass can also help determine its strength. The heavier the wall, the more durable the glass will be in terms of mechanical strength. When we design, we strike a balance between wall weight, function, and aesthetics. Generally, because of the manufacturing process for each, blown glass tumblers and stemware have lighter walls than pressed glassware. Keep in mind, however, that thick walls make a glass more vulnerable to thermal shock. That's because the thickness means that temperature changes take longer to flow through the glass wall. Let's go into our testing lab. Here is a case of our pressed mugs. We'll take out 4 of them. We'll mark 2 with tape to distinguish them. We'll drop silverware into the marked mugs. Needless to say, you've seen this kind of treatment many times in a restaurant. Now we'll place all the mugs, the damaged ones and the undamaged ones, into a dishwasher. The washing cycle is now complete. Now, imagine the restaurant is busy. Mugs are in short supply, and you need to serve a beer. The bartender is in a hurry. He calls for the mugs and pours a cold beer into the warm mug. Remember, according to our formula, for every degree difference between the temperature of warm glass and the temperature of the cold beer, there is 25 pounds of stress per square inch on the surface of the mug, which figures out to a stress in excess of 2,000 pounds per square inch. A lot of stress. As you can see, the glasses that were damaged were not able to withstand the thermal shock, because the nicks and scratches serve to concentrate the stresses on the surface of the glass until they reach the breaking point. The undamaged glasses, however, were able to withstand the thermal shock. The lesson here is twofold. First, undamaged, properly treated glass is surprisingly strong. But scratches so small you may not even be able to see them can intensify stresses. So what is it glass manufacturers do to strengthen their product? What are these processes? Heat treating, dura-toughing, and tempering all about. And how do they differ from one another? Basically, all of them are based on the same process: reheating glass and rapidly cooling it with compressed air, thereby setting up a controlled stress pattern in the glass. The controlled stress patterns increase the glass's mechanical strength and thermal shock resistance in much the same way that pre-stressed concrete is stronger than ordinary concrete. The differences in the various processes are in the amount of strength induced by heat treating, dura-toughing, or tempering, and the areas on the piece that are treated. Heat treated refers to the special thermal process which Libbey performs on many of our blown glassware products to increase the mechanical strength of the rim area. The areas around the rim are reheated to nearly the softening point and then rapidly quenched with air to set up preferential stresses. The strength increases from heat treatment range 3 to 4 times over annealed or untreated glass. This graph shows the impact strength difference between a heat-treated glass and the same glass in an annealed state. You see that the glass with the heat-treated rim area is able to withstand significantly more abuse. Dura-toughing is a similar thermal process, which Libbey performs on pressed glassware. Dura-toughing increases the already increased strength of a pressed tumbler by another 300 or 400%, which makes our pressed glass items some of the most durable produced for the food service industry. At Libbey Glass, we fully Duratough the entire surfaces of our plates and bowls. This helps increase both mechanical strength and thermal resistance, both very necessary for the kind of use that plates and bowls undergo. An important consideration when strengthening a piece is the fact that the stress patterns that are imparted to the glass during treating also affect the way it breaks. At Libbey Glass, we're careful to choose the precise type and amount of strengthening that's best suited to the food service industry. In other words, we want to produce a piece of glass that combines the optimum balance of strength with the most manageable breakage patterns. Inappropriate tempering can cause a piece of glass to shatter, almost explode on impact. Take a look at these two bowls. They're very similar in size and style. The bowl on the left is a Libbey Glass product that has been Duratoughed over the entire surface, and the one on the right has been tempered to a much higher degree by one of our foreign competitors. This spring-loaded center punch ensures uniform impact. When the Libbey product fails, the breakage is relatively uneventful. The pieces are large, easy to see, and clean up. The reason is that Libbey is able to monitor the Duratoughing process so that the stress patterns are controlled. However, watch while the bowl on the right breaks under an identical impact. As you can see, the breakage is much more violent, showering glass fragments over a much greater distance. And the pieces are smaller and harder to see. The reason is that the competition's bowl has been tempered to an unnecessarily high level. The dangers that this type of glassware poses to a food service operation are clear, which is why Libbey Glass has worked hard to balance the need for strength against the need for controlled breakage. Watch as we conduct the same experiment with our Embassy glassware and two copies of the Embassy pattern produced by two different competitors. Again, the breakage is violent, as tiny pieces are strewn over a surprisingly large area. Now, as you probably gathered, the people who handle glass in the workplace have as much to do with its durability as anyone. The more carefully glassware is handled, the longer it will last. And that's true of any glassware: annealed, heat-treated, Duratoughed, or even lead crystal. Libbey Glass has produced an entire video which outlines the basic do's and don'ts of handling glassware. You ask your Libbey salesperson, he or she would be happy to get a copy for you to view free of charge. In the meantime, we hope you've gained a new respect for the durability of our mugs, tumblers, wine glasses, snifters, goblets, bowls, and plates that you use so often. There's a lot of thought and study that goes into the style and durability process. And taking a little care in using them can help you and your customers get a lot more out of them.